We've already looked at the mathematics of simple interest. Now we want to examine compound interest, which is the way that interest is calculated in many real-world situations. Let's say you have $100 of principal to put in either Bank A or Bank C. For Bank A, you'll earn 1% interest per year that's calculated on the original principal of $100. At Bank C, you'll earn 1% interest per year, but at the end of each year, the interest gets added to the principal so that you have a new principal each year. What would be in these accounts at the start? It would simply be the $100 that was deposited for both accounts. Now, after 1 year had passed, for Bank A, you'll simply earn 1% of your initial principal, and 1% of $100 is $1. So now the bank owes you $101. And it's actually the same for Bank C as well. After 2 years, you will have earned $2 in Bank A. The reason why is you earned $1 for the first year and $1 for the second year, because it's always 1% of the initial principal that gets added to your account. And so we can easily go on to fill out the rest of the numbers here. The growth of Bank A is linear. So what happens at Bank C after 2 years? You're going to continue to earn 1% per year, but it's not calculated on the initial $100 anymore. It's calculated on the new principal of $101. So go ahead and calculate what 1% of $101 is, and then add that to the $101. 1% of $101 is $1.01. So if you add that to the 101, you get this, 102.01. It seems like a tiny difference, but let's do it one more time. Take the $102.01 and find 1% of that, and then add it to 102.01. I get 103.03. And then go ahead and find 1% of 103.03 and add that to the total, 104.06. Bank C exhibits compound interest growth, and it's an exponential type of growth. The banks are equal at time 0, and also here after 1 year. C is equal to A at the start, and also at 1 year. But after that, C begins to diverge from A. C forms an exponential type of growth, whereas A is linear growth. That's the difference between the simple interest and compound interest types. So let's just review what calculations I had done here to get these numbers. When it comes to simple interest, if no time has passed, then all you have in the bank is the $100 that you put in at the start. After the first year, though, we're going to take that initial principal and we're going to add the principal times 1% times 1 year. That's the interest, PRT. The formula I'm using here is P plus PRT. And that'll give us $101. After the second year, it'll be $100, 0.01 times 2 years. And that's how I got the 102. After the third year, take 1% of the 100, multiply by 3. That'll give us $3 extra to add to our 100. Now we have this. And that pattern just keeps going. And so, a formula for simple interest account balance is A equals P plus PRT. Now we can factor that into this. Factor out the P. And that's a formula for how much a bank owes you after simple interest accrues. But now what we'd like to do is we'd like to examine compound interest and how it's different. I'll do that one above. Once again, when no time has passed, no interest has been accrued. After 1 year has passed, we get 1% of the additional amount. And I'm going to write it a little bit differently this time. I'm going to write it as 1.01. All I did was I used this kind of idea of 1 plus the interest rate of 0.01, and then I multiplied that by the principal to give myself a little bit more than I had. This is 101% of what I had. Now what I'm going to do is I'm going to multiply this amount by 1.01, and this demonstrates the compound nature of compound interest. And you just keep going with that pattern. And that leads us to the general formula for compound interest, which is P times 1 plus R to the C. This is where RC represents the interest rate per compounding period, and C represents the number of compoundings. All right, let's add those to our page. Those are the formulas for the two different types of accounts.